Hello, this is the video that you can use to check your Frayer model for today. So your assignment for yesterday asked you to complete Frayer model 11 and 12. We've already talked about these terms in the book a little bit. So velocity, we talked about is a speed in a given direction. So remember, when they say given direction, they mean that it's going to tell you that, can't see that very well. They're going to tell you that direction. So it's going to tell you, for example, 100 kilometers eastward, or 60 meters per second to the southwest, 70 centimeters per second to the southeast. So if it has a speed, how fast you are going, and what direction you're traveling in, then it is velocity. So in the characteristics, I would also add the V equals D for distance / T for time, because you're going to calculate velocity the same way that you do speed, but you are adding a direction. And remember, it's not like that way. It's cardinal, compass, directions, okay? Non-example could be like something else you can measure, like time, distance, that kind of thing. This is a really good YouTube video. I recommend that you watch it. It has a cute little song that helps you remember the difference. It also talks a little bit about acceleration, which we'll touch on next week, but I'm not going to spend a great deal of time on it. You do that in 7th grade. The next term on your list is slope. So remember, we talked in class the other day that it's the steepness of the line. You can calculate it using rise divided by run, and we learned that the rise on the graph is the distance, because the distance will be plotted on the y-axis, and rise is how high up you have to go to find your coordinate. And then the run is the time. And remember, run is how far over you go on the graph to find your coordinate. That's the x-axis. You can see they put the x there and the y there. So if I wanted to know where this, line was crossing the graph, I would go, this is 0 right here. There's a lot extra over here. You'll deal with that later. I would rise up and then run over and see where it crosses the graph. Okay, same thing over here. This is 0 in the corner. For slope, you rise up and then run over, and that's where the dot is. Or you rise up and you run over, and that's where the dot is. You rise up and you run over, and there'd be another dot right there. Okay, so steepness. We've got the skier here. We talked about going the other direction during class. Like, if it looks really steep, like you'd be going really fast, that means whatever you're graphing is going fast. If the line is, kind of in the middle, it's not so fast. If it's less steep, they'd be going slower. If it's very steep, they're going faster. So same thing here. This hill, not too bad. This hill, very steep. He's going to go fast over here. So you need to know that this is the shape of the line on the graph. Steeper is faster, less steep is less fast. And remember, if you ever see a straight line, that means the motion has stopped. Non-example could be mass, weight, distance, time, those things by themselves. Okay? So make sure that you have some good examples on your page. Vocabulary words 1 through 12 are all fair game for the quiz on Tuesday.